Okay. Hi, my name's Eric Guiltinan. I work at Los Alamos National Lab, and I'm going to talk about the catalog program. Um, I only have my name on the slides because I'm a little bit lazy, but also because there's a whole bunch of people on the program. So there's probably over 100 members on the catalog program and over probably 30 members contributing to the field work, which I'm going to focus on this talk. So as I show stuff, I might say I or something like that, but it's not necessarily my work. It's a whole bunch of people contributing to this. This is a picture that I put to try to emphasize that from about 3 weeks ago. We were up at Shiprock on Navajo Nation conducting some surveys, and that's some of the team members that were with us. So the catalog program is a consortium of 5 national labs with the goal of identifying and characterizing UOWs, unidentified oil wells or orphan wells. And the 5 national labs I have here on the bottom: Berkeley National Lab, Livermore National Lab, Los Alamos, NETL, and Sandia. And we have identified 5 different field sites that we're looking at across the country. And maybe I just want to back up for a second. So the first oil well was drilled in 1859 in Pennsylvania. It's called the Drake well. It's drilled by, or organized to be drilled by a guy named Drake. So from 1850s is basically the birth of the oil industry. In about 1950s, you have the birth of sort of the oil industry regulation, right? So there's a lot of bills in the 50s, that state level bills that required permits to drill and set up different geologic surveys and things like that. So we have 100 years of oil industry drilling and everything that is completely, there's like very little records of them. And so those people who have done that have passed on. The companies who did it, they've been gone through bankruptcy or been sold or sold and sold again. And so a lot of those wells are completely lost. Then even in the 1950s, when you have the sort of permit process, it's on paper, right? It's on paper in the 50s, 60s, 70s, 80s, 90s, even 2000s. These papers might sit inside boxes in the basement of some geologic survey somewhere, and these wells can also be effectively lost, right? So it's estimated, and we don't know, but we think there's as many as 1 million undocumented lost wells in the country, and there's probably another 1 million identified undocumented identified orphan wells, meaning we know they're there, but the owner is gone. There's no one who's responsible for it. And so then the responsibilities fall to state, federal, or tribal agencies on the land that oil well is on. And so the infrastructure law included $4.7 billion to plug these wells. And as part of that, they gave some money to the DOE to set up our program to help consult the state, federal, and tribal agencies in finding these wells and characterizing them. So we have 5 different field sites basically across the country. This figure is a little hard to see. We do that because depending on the terrain, the sort of topography, the vegetation, if it's very hilly and very treed, it can be very difficult to find these. There can be different construction techniques, different well materials used throughout time and throughout geography. And so by studying in different areas, we can develop techniques that are right for the various spots. So I'm just going to share a couple of pictures, really. This is from, I guess I want to go back. There's 2 main field sites that we're operating right now that I'm going to talk about. One is Osage Nation. If you saw that Killers of the Flower Moon movie, that's the Osage. They were once the richest people per capita in the world. And they have like 50,000 wells in Osage County in Oklahoma. And we are working with the Osage Nation. We have an MOU signed with them. And then just 2 months ago, we got an MOU signed with Navajo Nation, and we were just out there 3 weeks ago. I don't really have data from that yet, but I can show you some pictures. So here's a square mile. You can see on the left with white wells indicated as active wells and red wells as abandoned wells. This is from a Bureau of Indian Affairs database that maintains a list of wells for Osage Nation. And then on the right, you can see this is that sort of intersection right here that you can see. And there we have one of our drones set up. We have very cool toys at LANL, very large. drones, although that one I crashed into a tree on its second flight and it is in pieces. So we fly over these with a couple, we use a variety of different sensors. I'm going to talk mainly just about these two. This is on the left is a magnetic plot. So we have a magnetometer. And then we also have a methane sensor. This is an Aries Pico. It measures sort of a point source of air, and it has ppb resolution methane. So this is actually from the same flights. So we have the magnetometer hung underneath the drone, and then we collect the methane. It's a pretty big area. It's a square mile. It has about 30 wells in it. And you can see from our magnetic signatures, we can see almost every single one of the wells. I actually do think we do see every single one of the wells. We see some spots in the database that say there's a well, but if you go there, there doesn't look to be a well, and there's no magnetic signature from it either. So there's a lot of errors in the database. There can be errors in the database positionally. I think a lot of it comes from conversion from township and range into GPS. There can be errors in the database where the database says there's a well and there is no well. And then there's the obvious error in the database when there's wells that aren't in the database, which are the ones we're looking for. So on the right, you can see all the various hotspots of methane that we found. This is 40 meters up in the air, and it's Oklahoma. It's really quite windy, but we have a very high resolution methane sensor. And here you see this really high hotspot, and you have basically winds going up to the northwest. And when we track this back, we found this well. This is an abandoned well. It's just open. Just drop a rock in there, and it's spewing methane. It's one of the highest methane emitters we found. It's over a kilogram per hour of methane. When you're standing next to it, you can smell it. And so that's out in Oklahoma. So now we're working with Navajo. So I've spent the better part of the last year trying to get this MOU in place, which we did. This is the Navajo Nation. It's a kind of small inset here, but it's very, very large. And a lot of the wells are located, a lot of the Navajo Nation wells are located in New Mexico in the Four Corners region. If you've never been up there, this is some of the topography that we're working with. It can be very steep-sided canyons. If you could see closely, there's a whole bunch of oil well pads inside there. And so this is just 3 weeks ago. We're out there. We worked with the Navajo EPA to identify different sites to fly old oil fields. Some of these oil fields date back to 1905-ish. We have a whole bunch of different types of drones and sensors. These are folks from Berkeley. They drive around with some sensors. Actually, out in Oklahoma, we're able to, at highway speeds, find a natural gas pipeline in Oklahoma that was just, some valve was left open and it was just spewing out, and they managed to find it. It's pretty cool. And yeah, pretty cool sites. We got to work next to, we're in Shiprock, the city, but then this is Shiprock, the actual rock. It's pretty cool. Yeah, that's it.